the Bluetooth Mesh internal training. In this session, I'll talk about provisioning and configuration. So what you will learn from this session are the fundamentals about provisioning and configuration, about the procedure of doing provisioning to add a node into a mesh network, about two different types of provisioning bearer, which is advertising bearer and GATT bearer, and talk about the difference between provisioning and configuration, and also the different types of advertising packet, including normal mesh advertising, beacon advertising, or simply GATT connection advertising. And then we have two sessions of hands-on exercise, one with the NF Mesh app on the phone and one with the Python script on PC, which is more comprehensive. So first, introduction about provisioning and configuration. Provisioning, by definition in the spec, is a process of adding an unprovisioned device, from now we call provisionee, to a mesh network, and is managed by a provisioner. So there are two main provisioning protocols, one with PBADV, which is the advertising bearer, the normal mesh bearer, or it could be the PB-GATT, which is using the Bluetooth Low Energy connection. This is for those devices that doesn't support mesh natively. For example, on a mobile phone, you can use GATT service and a BLE connection to do provisioning. The provisioner recommended by spec to be a smartphone or other mobile computing device, such as a laptop. So it's not recommended to use like embedded device like our chip to be as a provisioner, mainly because of the limitation of the computing power and the storage size of the provisioner. So in short, what the provisioning procedure is: first, the provisionee advertise the provisioning beacons or advertising as a connectable device, or both of them if it supports both PBADV or PB-GATT. PB stand for provisioning bearer. Then the provisioner will scan and invite or connect the provisionee. The provisioner and the provisionee then exchange public keys, do authentication, and then establish a secure tenant to exchange provisioning data, including unicast address of the provisionee, device key, the network key, and the IV index. So we'll go into detail of each of the step. First, we talk about advertising beaconing. This is the beaconing on the advertising bearer, not on the GATT bearer. So the provisionally advertise unprovisioned device beacon that include the device UUID and also the OLB information, that if the provisionally support like any out-of-band way to exchange a public key, such as the QR code or the barcode or the NFC. The invitation, the provisioner will start scanning for the device beacon, the unprovisioned device beacons, and when it finds the beacon of the device it want to do provisioning, it will send the invitation to the device. and the device will start seeking user attention, for example, blinking an LED or beeping when it received that invitation here. And there is an attention duration field included in the provisioning invite to tell how long the provisionee should do this blinking or beeping. And then the new device provisioning should reply with the provisioning capabilities. Include in this capability is the number of elements inside the new device, the OOB support for public key and the authentication key that the device support, and also the I/O capability for authentication, such as any keyboard input or LED blinking or numeric display. It should be in this I/O capability. The next step is to exchange public keys. As you know, that is difficult to send keys securely. For example, in legacy Bluetooth pairing, uh, if someone can sniff the pairing process, they can get the keys. That's why Bluetooth need to introduce the secure connection pairing. It's very similar to secure connection pairing. In Bluetooth Mesh, we use elliptic curve Diffie-Hellman to establish a shared secret over insecure channel. So we exchange a public key, and in combination with a private key, we come up with a shared secret or session key to do encryption of any flowing communication. There are two ways of exchanging the public key. One without the OOB. So simply the public key is sent over an open connection with no encryption or any OOB. The ECDH calculated based on this exchange of public key. Of course, the attacker can sniff these public keys, but if they don't have the private key, they cannot get the session key. The second method of exchanging the public keys is with OOB, which is more secured. So if the new device mentioned in the provisioning start package that is going to use OOB public keys, then the public key of the new device will be sent to the provisioner by either reading barcode or scanning NFC or reading a number to get the key of the new device on the provisioner. And then the provisioner will send its own public key to the new device traditional way, publicly via mesh. So that's how it's exchanged the keys. So after we have the session key calculated, the link will be encrypted, but it's not authenticated, meaning we are not sure if the device we are provisioning is the device actually we want to provision. So the provisioner then can choose a way to authenticate the device based on the I/O capability exchange. So there are four different ways of authenticate the device. First is no OOB, meaning no authentication. Second is static authentication, meaning there is a hard-coded key on the provisionee and on the provisioner that they can use to do provisioning. The third one is output, meaning there should be an LED or display on the provisionee that can display, and the provisioner need to input that number to have the match authentication key. And the last one is input, where the provisioner will display and the new device will have to uh, input that number and calculate the authentication value. Here is example on static authentication or no OOB authentication. So simply the authentication value is known on each of the device, and they just need to generate a random number on each of the device and hash it with the authentication value to get a confirmation number. Then they exchange the confirmation number. After that, they exchange the random number that they generated, and by having that random number and confirmation number and the authentication value, they check if the confirmation is matched with the random and the authentication value. If it's not, the provisioning procedure will be terminated. The next one is provisioning or authentication using OOB. So in this case, we're talking about, for example, output on the provisioning. The provisioning will select a random number and use LCD or LED to blink the random number like 3, 4, 5 times, or displays the number or beep a number of times. And then based on that input, based on that output, the user on the provisioner will have to input that random number in, and then again we'll have to do the confirmation and generating random number and hash with the authentication value. So if this is for output, but for input it's very similar. It's display on the provisioner the number, and on a new device you have to type it in or have to squeeze the device or press the button that several times to match with the number to get the number exchange via OOB. So after we have done with exchanging the public key and generate the session key, and also have done the authentication, we can start actually do the provisioning, which is the distribute of the data, provisioning data from the provisioner to the new device to assign the device to the network with all the information needed. Inside the provisioning data, we have the unicast address that's sent from the provisioner to the provisionee to assign the address of the primary elements. Because we have exchanged the number of elements inside the new device, the provisioner know which address range the new device will have, because each element will have one address, which is the increment of the primary element. For example, if the device has 3 elements on it and it's received an unicast address of hexa 10, for example, then the first element will be 10, the second will be 11, and the third one will be 12 hexa. The next one exchanged is a network key and the key index of the main network key. Third one is a device key. The device key is useful because it will be used by the configuration client and server to exchange more data. The device key is only known to the provisioner and the provisionee. Each new provisionee will have a different device key, so they don't share the device key. The fourth one is an IP index that's currently using in the network. So above we just talk about using OOB or not OOB, how we exchange the public key. So we only consider that it is secure provisioning if using one of the following method. First, if the public key is exchanged using OOB, meaning reading by a barcode or reading using NFC, and a static OOB of any size, then it's considered um, secure uh, provisioning. Or doesn't matter how public key is exchanged, it could be exchanged publicly or is exchanged OOB, but the OOB for authentication could be input numeric, input alphanumeric, output alphanumeric, and the OOB size of this of at least 6 octets. So if you do like input of 6 bytes or output of 6 bytes of at least 6 octets, then it's considered a secure provisioning. Any other method will be considered insecure provisioning. For example, if you do public key exchange without OOB and then you do blinking meaning that you only has one digit up to 9 or up to 9 or something, you can control it, but it cannot get to 6 octets, then you are not considered secure provisioning. It's insecure provisioning. So that's it for provisioning. After the provisioning, a node can start to receive and relay message packets because it now has the unicast address, it has the network key, so it actually can decrypt packets to know where to relay the message to check if it's the message for itself. But we still need to do some more configuration, such as set up the model subscription and publication address, assign application key, and we need to provide we need the information about the models, the elements inside the new node. That's we need to do configuration. It's the next step after provisioning to set up the node to the network. The configuration messages are special compared to a normal mesh message because it's encrypted using network key and device key compared to the normal mesh message is encrypted using application key and network key. Application key on access layer and network key on network layer. As I said before, the provisioner only the provisioner knows the device key of each node, and each node has different device key. The provisioner needs to store this into a database. And we have a configuration model. It's like it is similar to any other model, like generic on-off model or simple on-off model, but this is the core model, the foundation model of mesh, and usually config client will be on the provisioner and config server must be on the primary element of the node. So by having the device key, we are avoiding to have like any node configure the other node. It's only the provisioner can configure a node. This is not allowed. This is just another image showing how the config client talking to the config server and how it's located on the node. So it's very similar to a generic client model or generic server model. You can see, but yeah, there is only requirement that the config server model have to be on the primary element of the node, and usually the config client will be located on the provisioner. Of course, it can be located on a normal node, but that node need to get the device key of this provisioning from the provisioner to be able to talk to the config server. So during the configuration, The config client will request composition data from the config server. In this composition data, there will be included the company identifier, for example, Nordic Hexa 59, the vendor assigned product ID, the vendor assigned product version, the number of replay protection list entries in the device, how big the cache is, supported features if the node support relay or proxy features or friends or low power features, and element description of location of the element, the number of model and the model ID located on each of the element. This is similar to service discovery for BLE products to get the attribute table. After the configuration client has the composition data, then we can add in the application keys. It can be multiple of them. Then we have to bind the application key to the network key. In our SDK, we don't support or we don't show exchanging multiple network key yet. So mainly the app key will just bound to one net key. And then we have to bind a model to the app key. For example, if we have a generic on-off switch or server, then we have to bind it to the app key of the light bulb, for example. Or if we have another model on the provisioning or on the device, for example, a lock, we need to bind it to the lock app key. And then we have to, this is optional, to configure the element to the publication address of the model or subscription address of the model. They are optional. And then after that, the node is ready to use. You can start sending a package saying group A turn on, and if it's the node is subscribed to group A address, it will process that command and then turn on. Those steps I just talked about was about using advertising bearer. So those steps can also be done via GATT connection, Bluetooth Low Energy connection, and using GATT service. There are two different mesh GATT services. One is the provisioning GATT service using mesh provisioning service, and the second one is the normal proxy mesh. So they are different services. The provisioning phase using mesh provisioning service, but the configuration phase using the regular proxy mesh called mesh proxy service. So there are two different services here that you need to be noticed. And the provisioning has to be done with direct connection to the provisioning. By spec, there is no remote provisioning. The remote provisioning we provide in our SDK is proprietary. But the configuration step can be done via other proxy node relaying meshes, because it is using the regular proxy mesh, and is after the proxy it will be sent as a normal mesh packet and can be forward and relay in the mesh network. So configuration can be done remotely by relaying message relay start from the proxy node. So because of the two different services in our implementation in our SDK, we actually reset the sub device after provisioning, so that we reconfigure the GATT table to switch from mesh provisioning service to the mesh proxy service on the sub device of the provisioning to get the configuration. So let's have a quick look on the advertising packets. Different advertising types. There are actually 4 different types of mesh advertising. The first one is a normal mesh advertising packet. If you scan for mesh packet and if you see the advertising ID type is hexa 2A, that means it's a normal mesh packet. But if you see that the ID type is hexa 2B, that meaning it's a mesh beacon advertising type. Mesh beacon can be the beacon, security beacon, telling that there's a key refresh or there is IV index update. And the next one is the beacon type of hexa 29. Then it is a provisioning advertising bearer provisioning beacon. It will be advertised with the ID type equal hexa 29. The third one is the PBGuard provisioning advertising. This is a connectable advertising packet that I mentioned earlier. And if inside that you see the mesh provisioning service in the service UUID list, the mesh provisioning service has a value of hexa 1827. Then you know that it is connectable advertising for provisioning, and you'll see the service UUID with hexa 1827, and then you see the device UUID inside that packet, as well as the OOB information on how the provisioning can support OOB, for example QR or NFC or a number printed on the back, for example. So this is the OOB information that included inside the connectable advertising packet for provisioning via PBGuard. And the fourth one is the GUARD proxy advertising. It is a normal connectable advertising packet for proxy service, meaning this is a proxy for the phone to connect to the network or the device that doesn't have IDV to connecting to the network. It's not about provisioning. It could be for configuration, of course, or for normal mesh operation. And the mesh proxy service has a value of hexa 1828. So this is how you can see if you do scanning using a sniffer, you can find, you check if it's advertising as to get provisioning, there's a new device want to get provisioning, or it's just a node that is provisioned and then advertising as a proxy. When advertising as a proxy, instead of device UUID, you can have the network ID here in the payload. So here is a figure on how we do PBGuard provisioning. So first, unprovisioned device advertised as a connectable provisioning device, and the phone or the provisioner will establish a connection, and the provisioner by provisioning service client will do the service client on the GUARD table will exchange and do provisioning to the server on the provisioning. The step is the same as what I just discussed earlier with the advertising bearer. And you see that the provisioning service is 1827. And this is using GUARD directly. You don't need a mesh stack on the provisioner on the phone to do provisioning, to do authentication, to exchange the public key, and to assign unicast address and network key and so on. And the next is to do configuration. So as I said, when do configuration, the mesh node will advertise as a normal proxy node, and then the mobile phone will connect and then use mesh proxy service instead of mesh provisioning service as in provisioning. So it will use mesh proxy service to start talking to the proxy server, and then on top of that we'll have a configuration client, a mesh configuration model talking to the Bluetooth mesh stack. It could be the minimum, it could be full mesh stack, and then it will via proxy service go to the configuration server on the mesh node. So in this setup, to do configuration, you need to implement a mesh stack here to receive and process a mesh packet from the proxy service up to the configuration client. So there's a difference between configuration and provisioning. I think that's it for the introduction part. Next, we will go into hands-on to actually see what kind of data exchange that those data that I mentioned in the slides, with how it will be exchanged between the provisioner and the provisionee.